Okay, so good morning. So November 8 to November 14 this week, no? Our coverage would be temperature measurement. Okay, please visit as well the YouTube channel. Okay, so allow me to share the YouTube channel. Makita na ba? At the bottom part, no? Kita ninyo ang coverage na temperature measurement. So I'll be playing the introduction, no? Introduction to measurement.
Hey there guys, Paul here from the engineeringmindset.com. In this video, we're going to be looking at contact temperature sensors to understand the different types and the basics of how each one works. We'll look at the main types being the thermocouple, the RTD and the thermistor. If, after watching this video, you want to learn even more about temperature sensors, then I recommend you head over to Danfoss Learning and check out some of their e-lessons. They have self-guided online courses that will take you deeper on both the technology and the theory behind temperature sensors. The e-lessons are absolutely free, so just use the link in the video description down below to head over to the Danfoss Learning site and create your account today. So how do we physically measure temperature? We all know we can measure temperature using a thermometer. This is a very basic design used for hundreds of years. It's simply a sealed glass tube which is partly filled with some liquid like mercury or alcohol. As heat is applied, the liquid expands and rises up the column. The height of the column is divided up and marked to correlate it with known temperatures. For example, water boils at 100 degrees Celsius and it also freezes at 0 degrees Celsius. So as the liquid expands and contracts, we can easily read the temperature. This method is easy for humans to use, but it's slow, it's not the most reliable or accurate, and we're pretty limited on temperature range. So we need a fast and accurate way to take digital temperature readings, which will allow computers and controllers to accurately monitor and autonomously control systems. So how can we take accurate digital temperature measurements? The oldest way to do this is to use a thermocouple. If you have a handheld temperature probe or even a multimeter which can take temperature readings, it's probably going to use one of these. But these are also built into solid cases like this for a much more rugged design. With a thermocouple, we connect two different metals together at one end and the other ends connect into a terminal block. And we basically use a voltmeter to read the voltage difference between the two. The voltage here will be very tiny. So how does this work? Let's say we held a metal rod on our hand and placed the other end into a flame. We know that the rod will heat up and this heat will travel along the length of the rod and up to our hand. What's happening here is the heat is exciting the atoms and molecules which form the material structure. The heat causes the molecules and the atoms to vibrate. The vibration is so tiny that you can't feel it in your hand. The excited atoms will allow their free electrons to move more easily and they will move towards the cooler end of the rod. This only occurs because there is a temperature gradient, a difference in temperature from one end to the other. So at the cooler end, we'll have slightly more electrons than the hotter end. And as electrons are negatively charged, we therefore get a slightly negative and positive charged ends of the rod. Voltage is like pressure. When we measure voltage, we're measuring the difference or potential difference between 2 points. If you imagine a pressurized water pipe, we can see the pressure using a pressure gauge. The pressure reading is comparing two different points also. The pressure inside the pipe compared to the atmospheric pressure outside the pipe. When the tank is empty, the gauges read 0 because it has nothing to compare, both are the same pressure. Same with voltage, we are comparing the difference between one point to another. If we read across a 1.5 volt battery, we get a reading of 1.5 volts. But if we try to measure the same side, we wouldn't read any voltage. We can only measure the difference between 2 points. Coming back to the thermocouple, if we connected two wires together and they were of the same material, let's say they were made of copper, and we applied heat to one end to create a temperature difference, then the electrons would scatter and build up at the cold ends, but they would build up in equal amounts in each wire because they are the same material. This means that they will both conduct heat equally and the temperature gradient is going to be the same. Therefore, our voltmeter wouldn't be able to measure any difference. However, if we connected two wires which were made of different materials, let's say one was made from copper and the other one made from iron, then the two metals would conduct heat differently, so their temperature gradient will be different. That means the electron buildup at the cold ends will also be different. So if we now connect our voltmeter to this, then we can read a voltage difference. So to make this into a useful tool, we just calibrate it by testing the device against known temperatures, and we mark down the voltages generated. Then we'll use a formula to tell the temperature from the voltage. For this to work best, we should submerge the cold junction into an ice bath. That way we get a voltage with a reference relative to 0 degrees Celsius or 32 degrees Fahrenheit. Remember I said that with pressure in a pipe, we are comparing it against the atmospheric pressure outside. That's because we know the pressure outside the pipe is atmospheric pressure. So for the voltage reading to be accurate, we need to measure against something we know. So we use ice water because we know this temperature is constant at 0 degrees Celsius or 32 degrees Fahrenheit. This method is mainly used in science labs. However, this isn't very practical for most engineering applications. So instead, to improve the accuracy, we leave the cold junctions at an equal ambient temperature, and then we compensate this difference by measuring the temperature of the connection and applying a formula to offset the error. To measure the temperature of the connection, we often use an RTD temperature sensor, which we're going to look at next in this video. This is also a fairly simple design, probably easier to understand than the thermocouple. They usually come in these type of designs for engineering applications with much more rugged casing. So how do these work? Well, we know that electricity is the flow of electrons through a circuit. We've covered this in great detail in previous videos, links down below for that. When we pass electricity through a material, let's say a copper wire, the material will have some resistance to the flow of electrons, and we can measure this resistance with a multimeter. Different materials have different resistance levels. The temperature of the material will change the resistance of the material. Most conductors will increase in resistance the hotter they get. That's very typical of metals. This occurs because as the atoms and molecules become excited, they move around a lot, so it's harder for the free electrons to get through without a collision. So using a formula known as Ohm's law, voltage is equal to current multiplied by resistance. This means that as long as we keep the current the same, a change in resistance will cause a change in voltage. And as temperature changes the resistance of a material, we can measure the voltage to tell the temperature. We will use a material like platinum, which has a near linear resistance vs temperature gradient. We test the material again at known temperatures to obtain the graph. For example, at 0 degrees Celsius, the material will have a resistance of 100 ohms, and at around 100 degrees Celsius, it will have a resistance of 138.5 ohms. There are some different designs for these types, but they're typically either film type, where the platinum is coated onto a ceramic plate into a pattern and then the whole thing is sealed in glass, or it will be a platinum wire, which is wound around a ceramic core. Again, this will be sealed in glass for protection. Thermistors. Thermistors have a few variations in design, but these two are fairly common: the flexible version and the more rugged fixed version. A thermistor is just a thermal resistor, meaning it's an electrical resistor which changes resistance with temperature. But there are two types of thermistors: the NTC or negative temperature coefficient and the PTC, the positive temperature coefficient. We saw earlier that the resistance of a metal typically increases as its temperature increases, and that was because the atom started to vibrate, which makes it harder for an electron to flow through the material without colliding. The PTC type thermistor behaves something like this. We call it positive because if we plotted the resistance with temperature, then we get an upward trend showing an increase in resistance with temperature. The other type is the NTC, or negative temperature coefficient. With this type, we use a semiconductor which behaves a little differently. As you might guess, we call it a negative temperature coefficient because when we plot the resistance of temperature, this type will actually decrease in resistance. This is to do with the structure of the atom of the material. If we look at a simplified atom of a metal, we have the nucleus at the center and then a number of electrons all on different orbital shells. A conductor has 1 to 3 electrons in its outermost or valence shell. Each shell holds a maximum number of electrons, and an electron has to have a certain amount of energy to be accepted into each shell. The electrons farthest away from the nucleus have the most energy. We need electrons to be able to move between other atoms in a material for it to carry electricity. Electrons are held in place by the nucleus, but if they can reach the conduction band, then they can break free and move. With a metal atom, the conduction band and the valence shell overlap, so it's very easy for an electron to become free and move. With an insulator, the outermost valence shell is packed. There's very little to no room for an electron to join. The nucleus has a tight grip on the electrons and the conduction band is far away. so the electrons can't reach this and escape. Therefore, electricity can't flow through this material. However, with a semiconductor, there's one too many electrons in the outer shell for it to be a conductor, so it will behave as an insulator. But as the conduction band is quite close, if we heated the material up, some electrons will gain enough energy to make the jump and break free from the atom. As more heat is added, more electrons move from more atoms, and so the material's resistance decreases. So its basic construction is just a piece of semiconductor between two conductors, and this is sealed with a protective coating. So, which one is better? Well, they all have different pros and cons. There is no perfect fit, it all depends on what you need the temperature sensor for. Consider that these are used for everything from water, steam, air, gas, refrigerants and oil. And they are installed everywhere from engines, air conditioning systems, air compressors, heating systems, hydraulics, production lines, etc. I've put together a rule of thumb table here to compare the different types. You can see they each have different ranges, accuracies and robustness, which is going to reflect in the price. Okay, that's it for this video, but if you want to continue your learning.
Okay guys, so that was the introduction, no, around 10 minutes. So maduggan ba ko? So allow me to start with this RTD. No? It was mentioned that there are other types of temperature sensors such as the thermocouple and thermistor. Okay, so we begin with RTD. Okay, so madunggan ako. Okay, so
Yes, sir.
by definition, RTD is resistance temperature detector. Makita raman yung slides, no? Then you notice that the symbol is just a variable resistor, no? Similar to a potentiometer na symbol. Then an example would be a film or thin film RTD and the wire wound. But among the two, it is the film type that is mostly common. Okay, so what is an RTD? So these are one of the temperature sensors, no, with predictable, no, predictable linear na response in terms of resistance, no. So this is mentioned in the video. This is one of the rugged design na RTD. Now, ma-notice din mo at the tip of the stem, it's a sensing element. Okay. Then it is if we're going to put it in analogy with a rose, no. So this is the petals, no, of the rose or the head. Then this part is the stem, no, yung stem or stem. Then you notice also that in terms of standard color coding of the wires, there are red and white as well as black and red. Okay, so again, no, it is noticeable that RTDs should be linear, no, linear gina ang ato ang mga temperature sensor as much as possible to make it predictable. Okay, kung non-linear na siya, it becomes unpredictable. Okay, so in this example, no, the RTD exhibits a PTC, na type, no, positive temperature coefficient. It means that it changes temperature in positive manner, no. Pasabutan na as the temperature increases, there is a horizontal axis. Kung may-increase siya, may-increase po na nga ito ang resistance. So that is what is known as PTC, no, or positive temperature coefficient. What's the opposite of PTC? Kabalo mo, what's the opposite of PTC? Anybody? Wala yung makatagan. So kung naminaw mo sa discussion sa video, the opposite of PTC is actually, very good. Actually, it is NTC. No, it is a negative temperature coefficient. So simply means that as the temperature increases, the resistance decreases. Okay, so what material is an RTD made from? Okay, so there are nickel, copper, no, nickel and copper, but ang pinaka appropriate or superior is the platinum. Okay? Now the question is, why is it that the platinum is the superior among the three, no, metals? Anybody na makakita sa graph na naka-superior ang platinum? Okay, superior ang platinum because if you're going to look at the graph, platinum is straight line, no? Whereas the copper is parabolic na siya, no, or exponential as well as the nickel. Okay? So that's why uh, it's very important for an RTD or temperature sensor to be linear para predictable siya. Okay? Okay, going to the next slide, no? So among the graph, no, it is the color green that is the platinum. In fact, it has a temperature coefficient of a linear increase of 0.385 ohms per degree, no? So straight siya. Unlike sa uban na kuan na mga metal na that could be made from pwede siya mong temperature sensor, mani lang different ng mga resistivity. Okay? So an RTD, no, has a range of negative 200 degree Celsius to 500, particularly the platinum. Okay? Ang platinum is nani ang range. Now, if it is in Fahrenheit, then it is negative 328 to 932 Fahrenheit. But then again, mas broader ang range sa thermocouple as compared to RTD. Okay. Okay, so we go now to the three different types of RTD, no? The thin film type, the wire wound, and the coiled element. Now, among the three, kanira ang thin film ang ako ang na-experience, and in fact, it is the most common type na no, sensor, no? The thin film RTD. Okay, so this is what consists of thin film sensor, sensing element. So na siya ceramic substrate, no? Embody ang ganing gitawag na platinum film, no? Gi-embody siya sa ceramic na material as well as the glass, no? Protektahan siya sa kana ng mga materials. Okay, so in fact, is familiar sa RS Components or RS Philippines? Familiar mo? Kung familiar mo, actually, the RS Philippines is one of the biggest electro-mechanical na supplier online, no? So, ang ato ang thin film type na sensor or RTD, kani particularly is class A, no? Gamay kini siya. Dayon, it cost around 300. So, barato na siya, 300. Way back when I was still working for process control, particularly a temperature process control, there is a customized RTD requirement. So, mao ni yung drawing, say mga certain dimension. Dayon asa ka ang ato ang ato ang sensor, no? The sensing element. Nakatagaan mo sa dapit. So actually kaning color black, no? Ning nasa tuga. So this is the thin film na sensor. Karon, kung gusto mo mutanaw sa iyang kanang external na external na physical na shape. So mao gini siya. So it has a head, na siya head, no? Terminal head. Then naabo siya kaning bulb niya na type. That's why ginganlan siya og flash bulb kay mura siya bumbilya. Okay? Then ginganlan siya bulb because ginganlan siya flash because i-mount nimo siya palubong, ilubong nimo siya. Actually this is customized RTD na sensor required for blancher or a pasteurizer for DCN or desiccated coconut. So money isa sa requirement nila. You should have this type of customized na RTD. Okay? Now, let's go to the next picture. So actually, I'm showing to you kung ano. Supposedly dili na ko ipakita, but anyway, never mind the supplier kung asa sa gikan. So this is a quotation, a sample quotation. So kung mabasa ninyo, the cost of that customized na RTD, no? In fact, it requires a hygienic RTD and using a PT100, a platinum 100 ohm na sensor. It costs around 19,000. Okay, so that's why expensive siya, no? Kaya 19,000. So going back to the to RS components, we're going to compare the cost of that 19,000 as compared to this uh, class A, no? Class A na na thin film PT100 around 300 pesos. So layo ra kayo ang 300 pesos o the 19,000. That's why one of the best practices in preventive maintenance or let's say best practice in the temperature control na system is dili kasi palit atong tag 19,000, no? Perhaps you could buy, no, siguro tulo lang kabuok, then you can maintain, no, you can maintain or you can constantly from time to time kung mag-breakdown ang imong flash bulb na RTD sensor, kanira pulihan imong RTD sensor. In fact, pwede pa gid man ni customize na pwede siya mabutangan og groove na pwede naman siya ma-open, no? Ma-open siya kung imo siyang ituyok din. Pwede din mo siya pulihan ang ganing imong sensor dere, no? By buying only 300 around 300 na thin film na na RTD na or PT100 na type, no? Imo din siyang epoxy dere. Of course, the existing na wires imo ra na siya i-recycle. Okay, so that was the one of the best best practices rather. So dili sige palit kay kung sige ka palit 19,000 mahal kayo. Okay, so we proceed. So there are also other types, no? The wire wound type, so inaana yung itsura. Okay, as well as the coiled sensing type or sensing element, so inaana siya. Okay, so we go now to the formula, no? So the linear formula of the temperature, the resistance of the RTD. So where R is the final resistance, the RO is the initial resistance of the RTD multiplied by 1 plus alpha. Alpha is the temperature coefficient, no? Then the delta T is T final minus T initial. Let's have an example. Okay. Ang gawas mo din ang answer. Sa ipadako. Para dili mo mabanat. Ang question na sa atong tanawon. Okay? So let us say you have an RTD, no, that the initial resistance is equal to 50 ohms at 20 degrees ambient temperature. And given pa din yung alpha na 3.92 times 10 to the negative 3 per degree centigrade, So the question now is, what is the final resistance? No? When the temperature changes from 20 degrees to the final temperature na 50 degrees. So simple lang yun, na kay formula na R is equal to initial resistance plus times 1 plus alpha T final minus T initial. So atong initial na resistance is 50 ohms. Then the alpha or the temperature coefficient is given multiplied by the difference between 50 and 20. So 50 minus 20 is 30. And therefore, you multiply everything, then you have the resulting unit is ohms, no? 55.9. So that is the resistance of the RTD at 50 degrees. Okay? Then another question, no? Given ang imong initial na resistance, 50 ohms, again, at 20 degrees ambient temperature, same alpha. However, the RTD sensor is immersed, or you could say a thermometer is immersed in a vessel containing a melting tin. So take note, tin is a metal that it was melted. So init-init gina siya. Ang pangutana ron, what is now the final temperature, no, or the melting point of the tin as the temperature rises to, as the resistance, no, increases to 91.6 ohms of your thermometer. So the same, no, na mga formula, no? But this time, imo lang iko ano, you look for the T final, no, kaning T. So you substitute everything. Kabalo naman mo sa algebra. This is the reason why you took algebra as your minor subject. Para dili na ako i-discuss yun sa pag-simplify. Then finally, the melting point at which the tin, no, mag-melt is at the temperature 232 Celsius. Okay, so there is another example. So, kamo na lang na study, no? It's the same thing. Okay, so we proceed to the next slide. No? How is an RTD made? Of course, no, inani ang comparison with different common materials such as copper and nickel. So, ang platinum has a range from negative 260 to 850 degrees centigrade, or normally around 500. No? But this is the ideal na range. For the copper, mas bubo yung range as well as the nickel. In terms of the merits, sa best gid ang platinum, no? In terms of linearity. Then, in terms of the base resistance, since we're using a PT100, PT means platinum, then 100 is 100 ohms at 0 degrees. Then, for the copper is 10 ohms at 0 degrees. For the nickel is 120 ohms at 0 degrees. And these are their temperature coefficients. May pangutana? Okay? So, a pure platinum has money ang temperature coefficient, no? 0.003925. Okay? And take note, at 0 degrees, this is, ang range niyan is from 0 to 100 degrees centigrade. So, mana siya yung validity sa iyang temperature coefficient. Okay, so nganong tuod gingalan ang PT100? Asa ni gikan ning word na PT100? So the PT means actually platinum, no? That is the tanaw ka sa imong periodic table, that's the symbol for platinum, PT. Then the 100 means 100 ohms at 0 degrees centigrade. Okay? So there are also PT1000. Na po PT1000. So siyempre pasabot sa PT1000. Pag may PT1000, it is made of a platinum and it has 1000 ohms at 0 degrees centigrade. So, mara na ilang kalayo na. Okay? So we go now to the table, no? So this is the table for a TT100. Manotice mo, at 0. So 0 ang column, 0 po ang row. It's 100 ohms. Pag diri na ka sa first column, pasabot 1 degree centigrade. So 100.39, 2 degrees centigrade, 100.78 ohms until 9 degrees centigrade, you're expecting 103.51 ohms. Pag 10, dire na ka sa 100, 3.9. Pag 20, 127.79. Pag mingon pagka 28, so dire 110.9. So this table is very important, no, for calibration. No? Pag calibration, you need to have this standard na table. And this is in reference to the temperature coefficient, which is 0.00385, or the alpha. Okay, so na may pangutana. Then, okay, so it's a reminder that RTD should exhibit linear na response, no, versus temperature and temperature. Okay, so ibalik ko yung table in this format as well as this one. Na magayoban patindog po na table. Okay. Okay, so RTD, so money ang usual na color coding. No? The color coding is say red and white. So money common na color coding sa imong RTD. Okay? So there is additional conditioning circuit for the RTD, no? Kaya nga naman kay taas man na imong wires, it could extend as up to siguro 100 meters. Kay 100 meters na length sa imong wires, then you need a conditioning circuit. So in fact, this is the conditioning circuit using a Wheatstone bridge. Kung familiar mo sa inyong circuit theory, the Wheatstone bridge or katong ato ang instrumentation amplifier, no, for the load cell, magyapon ni siya, ginabalik-balik ining Wheatstone bridge. Okay, so we go now to the different wirings of the RTD. So there are 2 wires, there are 3 wires, and there are 4 wires for an RTD. But among the 3, it is the 3 wire that is the most common. Okay, ano yung pinaka most common? Okay, so we'll start with 2 wires, so duha ka wire. So notice niyo na kay RL1 and RL2. Pasabot sa RL1 is the wiring, no? Extension wiring sa imong RTD could generate resistance as well. So that's why RL1, resistance lead of the wire, lead wire. So therefore, you'll be expecting at the terminal, no, there is a output nimo na side, you'll be expecting the summation of the total resistance, including the ang imong RTD na resistance. So there will be a problem kung ma-appeal ang R1 o ang R2 o RL1 o RL2, okay? Mag-change ang imong reading. That's why pwede pa din na niyo pag-represent ang circuit. So nag-effect ang imong lead wires or galing imong extension wire sa imong or instrumentation wire. So usually you use instrumentation wire kay braided type na siya. Pare similar na siya sa ng UTP, as STP, shielded type na twisted pair na siya kaning shielding, okay, braided man siya na pati foil, but it is stranded kay it's meant to be bend di man siya, no? So dili siya solid, unlike sa uban na mga twisted pair, solid siya, pero several man manang stranded gyapon. Okay, so pwede na niyon pag-consider na because there is a resistance sa imong wires, So let us say na kay 2.5 ohms on both sides, no? So times 2 na kay additional 1 ohm plus the resistance of your kuan RTD, no? Nag 1 degree lugar siya or some sort or more. So ang effect na yan ay i-add nimo dili na dili na 1 degree supposedly ang ano or 1 ohms ang reading sa resistance because of the effect of the lead wires or extension wires. Yeah. So dapat i-compensate na nimo by adding a conditioning circuit, na kay conditioning circuit makita nimo ni sa imuhang temperature controller or even a PLC, na kay additional module na you need to attach it to a conditioning circuit para inaniyo nimo pagtaon. Para ang effect sa imong L1 o L2 na resistance will be canceled out. Okay? Tinanaon sa pag 2 wire na RTD. Nanay ang conditioning circuit pagkataon. If it is a 3 wire, which is the most common, common is duha ka red ug isa ka white. So inaniyon pwede mo pag-distribute. Pag-distribute sa imong Wheatstone bridge. Okay? Okay? So na kay duha ka red and may white. So in general na kuan na butana to na in the simplest circuit na explanation para daw ma-cancel ang effect sa imong lead resistance, ang buhaton nimo is sa imong conditioning circuit or instrumentation amplifier circuit, na it's an op-amp man na siya. It's a difference man na, differential op-amp. I-minus nimo ang B1 minus B2. So kung ang B1 nimo is actually the voltage, including the lead wires resistance or extension wires. So mao na imong B1, then ang B2 nimo is ang katulang lead wires, no? That's why 3 wires siya na type, no? So pag i-minus nimo B1 minus B2, regardless kung unsa pa nilang resistance, then ma-subtract ang effect sa imong kaning imong lead wires or extension wires. Okay? So that's why there must be a conditioning circuit involved, no? Para technically mas stable ang resistance reading. Okay, so this is for the Adafruit. Yung Adafruit is for the enthusiast, electronic enthusiast. Kung gusto mo magpalit ug inyong kagalingang kuan, you can buy it online, particularly the Adafruit RTD sensor. So it's a 3 wire. Sa may ang range from -10 to 85. Okay? Mao ba na? Mao na yung range, but ang usual na range is -200 to 500 Celsius. Okay? So, there is also another version which is a 4 wire. Pero bihira na kayo na siya gagamitin. Isamok na kayo, daghan na kayo wires involved. Okay? Kaya na itong 3 wires. Same na gyapon ang principle ganiya. 4 wires. Okay? So we go now to from RTD sensor, from sensor, imuuna nato siyang transmitter. Okay? So if it is a transmitter, ano siya gitawag na analog output. Though temperature sensor or an RTD sensor is analog man na siya, kaya ang output niya is resistance. But this time, if it is a transmitter na siya, then it is a standard 4 to 20 milliamps signal output. Dili na mo gamit atong other standards, such as 0 to 20, 5 to 0 to 5 volts. Kabalo na mo sa meaning sa reason no? And as well as kung pwede nimo mag-add ka additional digital communication, then you could add HART. I-discuss na po na what is a HART protocol. Sa example, nakay ganing kuan, temperature transmitter, you notice na kaning mismong blue, this is the transmitter. Okay? Ano yung transmitter? Now, let us say you want to convert the temperature output or the current output, no, the 4 to 20 milliamps output to temperature. So taon man na nimo siya mathematically. So we know that linear man ang iyang ang response. So we draw a straight line. Particularly, we recall, no? We recall the equation of the line, y is equals to mx plus b, where y is the vertical axis, then x is the horizontal axis, which is the current, ang ganing sa vertical, which is the y, and the b is the slope intercept na sila nga constant. Okay, so kung naagay inani, 0 to 200, nakita ba na siya? Okay, so kung naagay temperature transmitter, 0 to 200, yan eh. So pasabot, 0 to 200, ang output is 4 to 20 milliamps. So, nasa certain range. So pangutana daw, how are you going to do compute mathematically, no? So, dapat gamitin natin yung itong formula of the line, equation of the line. So let us say instead of 200 degrees Celsius, ato lang nganlan Tmax na lang sa Tmax. So at first, we need to solve then the slope, no, the m, so which is the rise, patindog, which is Tmax or 200 degrees centigrade over the run, so which is 20 minus 4, so which is 16. So therefore, atong slope is Tmax divided by 16, or the m. Then applying that to our equation of the line, so ang y na to, mama na itong t, which is the vertical axis. Then the Tmax over 16, which is the m, the slope. Then the I is the horizontal axis, manang x. Then the b, wala pa tayo b. Okay, so kinanglan pa na to. Solbon ang b. So at this, kani bitong 0 point, initial point. So kuhaan mo na siya. 0 ang iyang temperature, then 4 ang iyang current. So therefore, 40 siya. Kung i-substitute nimo sa katong imong equation of the line, 0 ang I, then 0 ang temperature, T, then 4 ang I, then plus B. So B is now, masolve na natin B. So masolve na natin ang B, which is actually negative Tmax over 4. And finally, you have now the equation. Temperature is equal to I, current minus 4 divided by 16. So by the way, these are in milliamps times Tmax. Sama na yung formula now. Pero, if the span, no, ang span niya is dili magsugod sa 0, so pwede gamitan nimo ni na formula. So process value, let's say temperature, is equal to current minus 4 divided by 16 times the maximum process value or temperature minus the minimum temperature na span, plus the minimum process value. Okay, so pwede ninyo memorize it if you like. Okay, so we go now to the advantages of RTD. So RTD is superior in terms of linearity compared to thermocouple and thermistor, and it's more accurate, and there is no additional cold consumption compensation required, unlike in a thermocouple. Then, okay, again, linear na pod. Then, ang accuracy is very high, and the operating temperature is within the usual range, stable, okay, so on and so forth. Okay, however, there is a disadvantage, no? Smaller ang range as compared to RTD, as compared to thermocouple. So way back when I was still in the field, no, there was a certain requirement in oil refinery. So gaabot sila ba og mga 300 degrees centigrade. So it was they are using thermocouple rather than RTD. Though within the range sa RTD, pero dili na siya inana ka effective. Usually ang RTD kay mga dili mo lapas og 200 degrees centigrade. siguro na. Pero pag katong sa oil refinery, maabot man gid siya even more no, more than 300 manata. Okay? So that's why it is a disadvantage na smaller overall temperature range. Okay, it's not that sensitive, no. Dili kay sensitive ang RTD, mas sensitive ang thermistor of ang thermocouple. Dayon, because dili kay siya sensitive, mao ni ang problem, no. Mao ni ang usual na issue. Slower iyang response time. Then it is more expensive, no? More expensive than the thermocouple and the thermistor. Dayon, what else? Kaning ga-require siya og 3 to 4 wires. Disadvantage. Because of that, dili siya suitable for high vibrating environments. Okay, upat with ka-wire, upat with the book maglihok. Okay, so this is another table no, in comparison of the three common temperature sensors. No? Kita nyo diri ang advantages and disadvantages. Basahan na lang ninyo. As well as this one. Okay. That's the summary. Okay. Now, in terms of application, no, kinasa na siya ba? As long as there is what is known as temperature process control. Kinasa na ninyo siya makita. Now, we go now to the examples. No, this is a temperature transmitter. Transmitter siya because naman siya display. Ang sensor, typical lang na temperature sensor, wala na siya display. So, ang temperature transmitter na. So, this is using a connection type, a flange. Kailan mo flange? No, managing kaning dish bitaw na type, this is a flange. Usually, common na siya pag mag-connect ka og mga pipes, na dagko ng pipes. Gusto nimo i-connect silang duwa. Sometimes, dili na i-weld. Sometimes, it will be using a flange type na connection. As well as these other types, na siya head. Sometimes gina-clamp lang siya, no? Okay. Then there is also another shape of a temperature transmitter or sensor. So you cannot generalize the shape of the sensor. Mo na lang basahon na lang mo siya. Okay? Then there is also this concept of redundancy. Now, this is very important. Pasabot sa redundancy is more than one. More than one sensors ang imo ibutang para to avoid downtime. Kaya sometimes manggod na ay ganang gitawag na uncertain na result, no? Pag mag-check nimo sa first na temperature, dako kayo or ubos. Para makaingon ka na is the RTD sensor defective or kuan ba nang naay something wrong. So there is a comparison, at least na kay duwa, no. So at least ma-compare nimo, particularly in a critical critical control point, no. Kung ka CCP, kinahanglan gid mag-redundant ka kay or else downtime na siya, shutdown ang imong line. Kay wala ni pass a certain standard because it's critical. Okay, so napay ganina type, no? Sa thermowell, no? Thermowell, asa gito thermowell. Napay ganing wireless na type na temperature transmitter. Wala na ko ng thermowell. Okay, anyway. So kaning thermowell, paano siya kanang it is kanang mura sa jacket, no? Jacket sa mo ang RTD or temperature sensor na ang kaning thermowell is the thing that is exposed sa kaning harmful na substance or product. Ang imong RTD or sensor, it's not exposed, no. Murag nidikit lang siya sulod, murag iyang kuan embodiment. Okay, so we go now to an example of a transmitter. So mabala nimo ang head transmitter niya, na particularly inside there is a mga rugged type na enclosure or embodiment. Na siya plus and minus 24 volts na supply. Okay? Pag wala na siya, usually kanilang tulo, then it's a terminal block. Terminal block lang siya. Kung asa nimo i-terminate ang imong 3-wire or 2-wire na RTD. Pero pag naana siya positive and negative na supply, it's a temperature transmitter. Maura na ilang kalainan. That's why pwede siya mag-swap. Pwede siya swappable. So, ano siya, no? Mura siya rose. It looks like a rose. Manang there is a brand na Rose. Rose mount na ang brand. Okay, mura siya rose. So, nasa cap or cover. Then there is this one, no? The head transmitter or the transmitter itself. Ano yung mag-generate of 4 to 20 milliamps na output, provided if you're going to supply it with 24 volts. Okay. Now, there was this scenario in way back when I was still working in a temperature controlled na equipment. Nabali ang steam, no? Nabali mismo ang sensor. Particularly, ano siya, Rose mount na brand or Rose mount ba to, Rose. Nabali siya. So, it's a temperature transmitter. So, in fact, money yung yung tip sa yung or stem sa yung sensor, nabali siya. So, gisukod lang niya kay para for purchase request para ibutan ng mga specification niya. So, the question is, what will you do kung wala na may spare? So, wala na may naka-spare ani kay nalimtan po doon create of spare. So, it's very important na may spare. So, ang gibuhat na mo is, no, based on ganing drawing ganiya dire sa taas. So, ang difference naman sa temperature, typical na temperature sensor o temperature transmitter, isang ganira mang ilahang head transmitter. So, among gibuhat, gibalhin na mo sa existing na temperature sensor, gitanggal to na mo to yung terminal block na pareha ra gyud itsura, na circle gyapon ka, pero wala lang siya katong terminal for the positive and negative 24 volts. So, tanggalon to nimo. Ipuli nimo ning katong existing na temperature transmitter sa katong nabali. Ang nabali raman niya isang sensor, ang ganiyang steam sa sensor nabali. So, among gitanggal ni, i-shoot na mo dire, so nahimo na siyang temperature transmitter. Okay? So, inana lang pag-diskarte. Whether na wala mo yung temperature transmitter. Okay? So, pwede rin mo i-convert ang imong temperature sensor, no, to a temperature transmitter. Ibalhin lang nimo ang transmitter. Provided na ang imong PT100 na sensing element is okay. No? Para okay ang tanan. Okay? That's how we deal with this problem. Okay, mao dining thermowell. Late din ni nabaliktad sila ng picture. Okay, this is a thermowell, it's a protection, no? Para dili ma-expose diretso ang steam sa imong sensor sa imong temperature sensor. In fact, nasa gitawag, thermowells provide protection. Particularly if the process involves corrosive, no? Or abrasive. Madaot diretso ang imong temperature sensor or temperature transmitter. So, imo siyang i-embodiment na siya enclosure. Thermowell ang tawag. Okay, so this is the one, no? Again, the RTD. Then for the thermocouple, ang bantayan lang ni mo na is the color coding. Ano yung color coding? Ano yung color coding? And the most common are the J and K. Pinaka-common yun ang K. So kung makita ni mo diri ang range sa imong kuan, ang range sa imong thermocouple is 1,000. Ang imong RTD di siya kalapas og 1,000. Okay? Whereas the J is mas ubos-ubos or sa RTD. Ang pinaka-common gid is ang K. But usually kanirang duha. Okay, kung magbuy ka og wire na thermocouple wire, ang buhaton na nimo na is para may mo siyang thermocouple, imo ra siyang short ang tumoy. Short na nimo ang tumoy. Okay. Ako na yung pinakabarato, thermocouple. Then, napo siya inani na type na connection. Namura siyang plug. Then, this is the empirical formula. Wala lang, to exercise lang itong gitawag na analytical na skill. So, ano yung mga range, no? For the different types of thermocouple. So, natay sample diri na problem. No? A thermocouple produces an electromotive force or voltage. No? So, a thermocouple is an active device kay naman siya output na voltage as compared to the thermistor and the RTD. Resistance sa mga ilang output. Kani is lagi siya voltage. Dayon, it is a two-terminal device. So, dili ka malipat kay ang RTD is, di ka mo gamit og two-terminal. Three-terminal man ang most common sa industry because of the effective na compensation, no? Sa katong lead wires or katong circuit niya. Mas effective siya as compared sa katong two wires lang. So, dili ka malipat. So, commonly, kung 2 wires na siya, then it's a thermocouple. Pag 3 wires siya, then it's an RTD. Okay? Okay, so, mao ni yung formula. Then, alpha and beta. So, di na ako explain. Sulban yung balik kung sakto ba niya yung output na temperature. Okay? So, it involves quadratic equation. Na ano may algebra. Okay, so kabalog siguro mo solve og quadratic equation. Okay? So naipangutana? So kung walay pangutana, let's proceed to our video. No? Video na punta. Okay, makita niyo yung video or the YouTube channel, atong YouTube channel. Particularly, we're going to thermistor. No, wala pa taga sample of thermistor. So one of the practical gitawag niya life skill is dapat aside from industrial na point of view, kabalo pod mo gatong from home appliance na point of view. So I'm going to play this video, particularly deals with thermal.
Many household appliances can be repaired with a simple part that costs under $1. Hi, I'm Peter Mooley, founder of Fix It Clinic, a community repair workshop where we teach people how to disassemble, troubleshoot, and repair their broken consumer electronics and household appliances. We provide Fix-It coaches and tools to help guide you through your disassembly and repair process. But even if the item isn't fixed, there's lots to learn in taking it apart and understanding why it stopped working. A thermal fuse is an electrical safety component placed in lots of appliances. If the appliance overheats, the thermal fuse fails, cutting off electricity through the circuit. Thermal fuses are found in a huge selection of devices, pretty much any device that heats stuff up. You can also find them in motorized devices like blenders, coffee grinders, and food processors. So, why do thermal fuses fail? With hair dryers, we've seen lint and hair clog up the intake, cause the internal temperature of the hair dryer to rise and exceed the rating of the thermal fuse inside. But often it goes bad for no good reason whatsoever. So, how can you tell if your thermal fuse is blown? Well, the most common symptom is that your device that's supposed to make things hot doesn't. You might also find that your device won't even turn on at all. However, if this is the case, save yourself some work by confirming that your device's plug and power cord are good before you start tearing into it. Once you've figured out that you might have a faulty thermal fuse, you can confirm it's bad by testing its continuity with a multimeter. If the thermal fuse has failed, the multimeter won't beep. If you determine that you do need a new thermal fuse, there are a couple of things to know. First, they're probably not available at your local hardware store, but they are readily available and easily obtainable through eBay. It just may take a little while to get it from overseas. Second, the thermal fuse will have printing on it indicating its temperature rating in centigrade. So make sure you get a replacement thermal fuse of the same rating or as close to that rating as you can get. To replace a thermal fuse, you first move the insulation sleeve out of the way, making sure to save it to put around the new thermal fuse. Cut the thermal fuse out of the circuit close to the component, making sure to save the wires. You can often use the wires to just wrap around the new thermal fuse, so you don't even have to do any soldering. Replace the thermal fuse, recover with the insulation sleeve if there was one, and reassemble the device. We hope this thermal fuse fix can help you keep your item in service for many years to come. If you tried this repair, whether you were successful or not, please tell us.
Okay guys, so kita naka-repair na or pulley of thermal fuse. Ako kay naka-pulley na ko sa planta, naka-pulley na pud ko sa ilang mo planta no iron ba. Planta naka-pulley na pud ko sa rice cooker. So there are instances na dili mo work ang rice cooker uban gina short circuit ra nila. Dayon gatanawon na nila na sobra na kainit, palungon na dayon nila. Okay, pwede na pero dili siya advisable kay basig masunog ang plansa, masunog na lang yung balay. So, dapat pulihan mo siya og thermal fuse. Okay? So, kung wala mo ipangutana, then let's proceed to our next na video. So, our next video will be temperature transmitter.
Get vaccine-related facts on Google.
Welcome to my channel Instrument Calibration. If you are new on this channel, and if you have missed my previous videos, then you can find links in the description box. This is short video on how to connect RTD with temperature transmitter. First of all, let's learn some basic things about RTD. RTD stands for Resistance Temperature Detector. And it is device whose resistance changes with temperature. In other words, RTD has positive temperature coefficient, and its resistance increases as the temperature increases. In addition to this, RTD is a passive device. It means RTD does not produce an output on its own. In other words, external electronic devices are used to measure the resistance of the sensor by passing a small electrical current through the sensor to generate a voltage. In this section, we will learn about different parts of RTD. As you can see from the picture, that first part is thermowell. Thermowell protects RTD from process medium. Second number part is a measuring insert or RTD sensor. This sensor measures the temperature of process medium. Third number part is extension. And fourth number part is transmitter housing. And the fifth number part is transmitter assembly, or it is temperature transmitter. And this is a part where RTD wires are connected. Now, let's learn how to connect 3 wires RTD to temperature transmitter. As you can see, this is a typical 3-wire RTD. And I am going to connect this RTD to temperature transmitter. In this example, I will take E and HTMT82 temperature transmitter. As you can see, this is internal terminal layout of temperature transmitter. In this temperature transmitter, terminal number 4, 5, and 6 are for sensor input. In other words, RTD's wires are connected to these terminals. It will be shown in next slide step by step. In addition to this, terminal number 1 and 2 are for power supply. Now, let's go to learn how to do RTD connection. As we know that, all 3-wire RTD has 1 white wire and 2 red wires. First of all, connect white wire to terminal number 4 of temperature transmitter. And connect one red wire to terminal number 5, and another red wire to terminal number 6. That's it. RTD's connections are done. Now, next step is to connect power supply wires. As you can see from the picture, connect power supply wires to terminal number 1 and 2. Here, terminal number 1 is positive. So we have connected red wire to terminal number 1. And terminal number 2 is negative. So we have connected black wire to terminal number 2. And apply 24 volt DC supply to temperature transmitter. You can find power supply rating on the nameplate of temperature transmitter. For example, this E&H temperature transmitter supports 11 to 42 volt DC supply. Since different manufacturer have different power supply rating, it is advisable to check power supply rating of temperature transmitter before applying supply to temperature transmitter. Now we are done with wiring. So, connect display to transmitter. And check it's working by putting RTD in temperature bath. Once the working is confirmed, we can take out power supply connections, and mount the RTD at on-site for process operations. Thank you friends for watching this video.
Okay, so na may pangutana regarding the RTD and the temperature transmitter. Okay, so kung wala may pangutana, let's proceed to the calibration. Okay, so calibration na ta.
Fuji Denso, home and commercial appliances.
Okay, so this is one of the calibration activity. Calibrate nimo ang accuracy ang sa imo ang temperature na transmitter or sensor, but in this case it's using a temperature transmitter, no? So the name of this calibrator is what is known as a liquid temperature calibrator, or usually an oil temperature calibrator, no? So or gitawag niya oil bath or liquid bath dahil temperature calibrator. So imo ra nang i-bath ang imong kuan, ang imong sensor, no? But kuan nimo, ihulom nimo siya sa liquid or to clear an oil. Dayon, set nimo ang imong calibrator na siya kagalingan niyang temperature controller. A certain example is 250 degrees. So yung giset. Dayon dapat i-compare nimo ang resulting temperature sa imong kuano, sa imong process na end, no, which is kaning na kay handheld na kuano, ganing display, no. So kung pareha sila, then there's no problem. Okay? Ang disadvantage lang aning oil bath or liquid bath na temperature calibrator, you cannot do this inside the production area, no? Kay bitbiton man nimo, pag bitbiton nimo siya mayabo. So depende lang, no, sa scenario. So sometimes pwede, but most of the time dili, kay pag bit-bit pa lang nimo na mayabo siya. So that's why ang preferred na kuan na calibrator is not using the oil bath liquid temperature calibrator, but rather the dry block. Okay, so similar naman ang oil bath or ang liquid bath or ang dry block, no? Except that it's not using a liquid. na it's using kanang murag nakalimot ko sa substance pero mura siya ointment no sa iyang sulod. So dili siya mayabo. So sulod ba gyapon nimo siya kaning imong steam sa imong temperature sensor or RTD dayon imo ding ikuan on turn on imong device, of course naka extension wire no asa nimo i-plug ang imong appliance, then you compare dayon the resulting temperature. Kung ang temperature nila is different, there's a difference, then you make adjustment, no? Make adjustment. Okay, so another video. Doon na tamahuman.
Join the Baroka Supercharged Squad.
Welcome back to my channel Instrument Calibration.
So this is
If
the
you are
last
new on this
video.
channel, and if you have missed my previous videos, you can find links in the description box. In this video, I am going to show the calibration procedure of temperature transmitter. First of all, what do we need in calibration kit? Firstly, we need thermocouple or RTD simulator. Secondly, we need 24-volt DC power supply. Lastly, we need digital voltmeter to measure 4 to 20 mA output of transmitter. Let's learn how to perform calibration of temperature transmitter. As you can see, this is typical setup for temperature transmitter calibration. In this setup, 24-volt DC supply is given to loop power terminal of temperature transmitter. And digital voltmeter is connected in series with 24-volt DC supply to measure 4 to 20 mA output of transmitter. In addition to this, thermocouple or RTD simulator is connected to sensor terminals of temperature transmitter. And simulator is set to feed resistance values to transmitter. At this stage, we are all set to perform calibration of temperature transmitter. In this section, I am going to show how to perform zero and span calibration of temperature transmitter. First of all, in order to perform calibration of temperature transmitter, we need calibration range. For example, let's assume that this temperature transmitter need to be calibrated for range 0 Celsius to 40 Celsius. Also, let's assume that RTD-PT100 will be used as sensor after calibration. So, this is a reason that RTD-PT100 resistance table is being used for this calibration. As you can see from the table that RTD-PT100 has some specific or standard resistance values at some specific temperature. You can also find this table in manufacturer datasheet of RTD-PT100. We will use these resistance values to calibrate temperature transmitter. Now, let's start with zero calibration. As you can see from the resistance table that RTD-PT100 has a resistance of 100 ohms at 0 degrees Celsius. Now, set 100 ohm resistance in simulator, and apply this resistance value to transmitter. And measure milliampere in dVm. Measure milliampere should be 4 milliamperes. If it is not 4 milliamperes, then adjust to 4 milliamperes by rotating zero adjustment screw. For example, if measure milliampere value is 3.96, then rotate zero adjustment screw clockwise direction until it becomes 4 milliamperes. Once you are done with zero adjustment, set 115.54 ohm resistance value in simulator, and feed this resistance value to temperature transmitter. After this, measure milliampere value in dVm. Measured milliampere value should be 20 milliamperes. If it is not 20 milliamperes, adjust it to 20 milliamperes. For example, if measured value is 20.10 milliamperes, then rotate span screw in counterclockwise direction until it becomes 20 milliamperes. Repeat this procedure few times until you get exact values for zero calibration and span calibration. Once you are done with 0 and span calibration, we need to perform 5-point verification test to check calibration. First of all, apply 100 ohm resistance value to transmitter, and check the value in dVm. Measured value should be 4 milliamperes. After this, apply 103.90 ohm resistance value to transmitter, and check the value in dVm. Measured value should be 8 milliamperes. After this, apply 107.79 ohm resistance value to transmitter, and check the value in dVm. Measured value should be 12 milliamperes. Now, set 111.67 ohm resistance value in simulator, and feed this value to transmitter. dVm should give 16 milliamperes value. Finally, set 115.54 ohm resistance value in simulator, and feed this value to transmitter. dVm should give 20 milliamperes value. Once you are done with verification, disconnect simulator from transmitter, and also disconnect dVm from transmitter.
Okay guys, so na may pangutana. So ako sa ibalik ka dyan ta. Okay, so this kind of calibration is usually an off-site. No? Kanang naara ka sa imo ang calibration center. And particularly, ang i-calibrate lang is ang transmitter. What if i-calibrate nimo ang entire equipment, no? Temperature equipment. No? So, apil dapat ang sensor. So, ang may tabuan ni buhaton nimo, you're no longer using a thermocouple or RTD na simulator. So, ang imong buhaton gyud is i-connect nimo ang sensor, okay? And there's no need for the table, no? Di na maginang ng table na. Ang imo karon is ang table of the different temperature range. No, set nimo, set ba nimo sa kuan 40 degrees, sunod times 2 ba nimo 80 degrees up to sa katong kuan niya siguro 150% sa iyang kaning usual na operation na temperature. Now, let's say the operation niya is from 0 to 100. So, ang imong kuan, imong sample point is dapat kuan, no? I-divide siguro nimo from 0 to 150 or 120. Pwede rin na mulapas ng gamay. Dayon, ang buhaton nimo, ang disadvantage mo ganani kay you'll be needing a calibrated na digital voltmeter. So, duwa na imong issue na pa kay dry block na calibrator ug napagay kaning digital voltmeter na i-calibrate. So, para dili na ka magproblema na duwa ang i-calibrate, para di na ka magamit og digital voltmeter, katurang dry block ang imong ginapa-calibrate, no? Sample, pa-calibrate ba nimo ang iyang temperature na response sa kuan sa DUST, kikandak mo na sila og kuan standard na kuan calibration for your standard na kuan equipment or testing equipment. Okay? So pag magamit kag dry block, idungan nimo tong imong temperature transmitter, no? Imong ihulom dito sa kuan sa iyang dry block, dayon adto pug ka sa iyang layo ang iyang display sa iyang temperature transmitter, manginahanglan gi kag radyo, no? Duwa gid mo mag-conduct as kuano for the calibration. So magradyo siya. Ang imong dry block, let's say set nimo for buta na to 100 degrees centigrade. So after a few seconds, no, pag ma-reach na to niya, i-record pa nimo ang iyang response time pila siya ka seconds mo abot atong set point niya na 100 degrees centigrade. Radyo po ka sa pikas dito na naa-assess sa iyang control panel o control room kung pila pa ang display sa temperature para ma-compare ninyo, okay, so okay ra ang imong temperature transmitter as well as the sensor. Kani man gud na example, it's only the temperature, it's only the transmitter ang iyang gi-calibrate. Okay? Pero in terms of adjustment, sakto tingon, no? You can adjust the zero, no? The zero span. You can also the zero as well as the span. No? So, mao na siya ang buhaton nimo. Okay? So, magkuhan siguro tanong, mag-selfie ta para attendance before we end our class. Naaba mo'y pangutana? Wala may mga camera diya. I-turn on itong camera kay para natin attendance. Pero kung wala na mo diya, ay naapaday diya. Naapaday. Abi na kung wala na. Katong wala ikam, okay ra.
Sir, pwede ra dili mag-open og cam?
Pwede ra, okay ra. Basta, kung na mag-open og cam, or punto akong makapture. Okay? So,
Thank you, sir.
Ay, sakit lang. 1, 2, 3. Screenshot. Bye-bye. So, kasi na-stop recording din. Stop
Thank you, sir.
recording. So, ano may pangutana?
Wala na, sir. Thank you, sir.
Yes, sir.